Go.
Ready to go. Welcome to Mr. Holt Maths revision. We're going to do probability trees this time. So we've got a question. We've got a bag as counters. It's got 2 yellow, 3 blue and 5 green counters in it. Mr. Holt picks one at random. Mr. Ford picks one at random in that order. What's the probability of them getting the same colour? Key point here is the counters are replaced. So once one's been taken, it's put back into the bag. So we need to think about the first event happening. So that's Mr. Holt, that's me, picking out a counter. So we've got 3 possible outcomes. We've got yellow, blue and green, and then we need the probabilities for each of them. So we've got 2 out of 10, 3 out of 10, 5 out of 10, because there's 10 in the bag altogether, and the probability is given in the question. From there, we've got the second event happening, which is Mr. Ford picking one. So yellow, blue, green, and he's got the same options as myself: yellow, blue, green, yellow, blue, green. He's got the exact same probabilities because it's the same number of counters in the bag because it's been replaced. So it's just going to be 2, 10, 3, 10, 5, 10, 2, 10, 3, 10, 5, 10, 2, 10, 3, 10, 4, 5, 10.
Why have I got 3 stems and you've only got 1, sir?
Because if I pick a yellow, you could then pick a yellow, a blue or a green. If I picked a blue, you can still pick a yellow, blue or a green. And if I picked a green, you can still pick a yellow, blue and a green.
Okay.
So it's a different event. So the probability when we follow the paths, so we want the same colour. So yellow, yellow would be 2 temps for Mr. Holt, and then 2 temps for Mr. Ford. You times these together. Blue and blue is 3 temps and 3 temps. And green, green is 5 temps and 5 temps. Work them out: 4 over 100, 9 over 100, and 25 over 100. And at that point, when you've got your 3 probabilities, they're all over 100. Add them together. 25 add 13, essentially, is 38 over 100. It's not necessary to simplify, but can do if you want. The second option is you have the exact same question, but the counters are not replaced. So that would mean I pick out either a yellow, a blue or a green, and I don't put it back in the bag. So this is where it gets a bit more confusing. This is the higher level. If I pick a yellow, or any colour for that matter, there will be 9 counters for Mr. Ford to pick out the bag. So when there's 9 left, all of them are going to be now over 9. So whatever it is, over 9, over 9, over 9. And it's probably best just to get that written in if it's this kind of probability. Just get them all in there. Now, if I was to pick a yellow, that would mean there is 1 yellow left back in the bag. The blues and the greens would still be the same, so that's 3 and 5. That's one option. Then you kind of forget that and you think, well, if I chose a blue, what would happen? There would be 2 yellows. I've chosen a blue, so there would be 2 blues left. There was 3, so 2 left. And there was 5, so now there is, there's still 5 greens in the bag. If I was to choose a green in the first instance, there'd still be 2 yellows, there'd still be 3 blues, but now there'd be 4 greens. So you can see that the top number has reduced if I've chosen it. So we do the same thing, we follow the stem, so same colour, 2 temps times a 9th, 3 temps times 2 ninths, and 5 temps even, times 4 ninths. Same thing, 2 over 90, 6 over 90, 20 over 90, and then we can add them together, which is 28 over 90. So it's a little bit more difficult, takes a bit more brain power. You've got to think, if you've chosen one, what happens to the number? Bottom number is going to be reduced by 1 because 1's been picked. So just be aware, is it replaced, is it not replaced? Make sure you circle it in the question and highlight that. Alright, I hope that.